Assalamu alaikum. Today we are going to discuss chapter 8, where we are going to discuss data modeling advanced concepts. We have already learned in the previous two chapters that how to use ER diagram to create a data model. Now in this chapter we will learn about extended ER model. There are the extended ER model build on ER concept and add support for entity supertype, subtypes and entity clustering. So these are some of the new topics that we're going to discuss in this chapter. Then we will discuss the characteristics of good primary key and how to select it, and how to use flexible solutions for special data modeling case. We will study some use cases and see how can we implement those ERR diagram in relational data model. Okay, we will start with what is the extended entity relationship model. As we know that the complexity of data structure that is being modeled has increased, and application software requirement have also become more stringent, so it need to capture more information in the data model. So the extended ER model, which is sometimes also referred to as enhanced EER model, it is the result of adding more information, more semantic to the original ER model. So first we construct original ER model, and then when we add more information, more semantic construct to this ER model, it results into the enhanced ER model or extended ER model. Okay, for normal ER model, the diagram which we construct is called ER diagram. So for extended ER models, the diagram that we create is called extended ER diagram. Okay, in extended ER model, we use the concept of entity supertype and entity subtypes. Okay, if we look at the definition of entity supertype, we can define it that entity supertype is a generic entity type which is related to one or more entity subtypes. And if we look with respect to the characteristics, entity supertype contain common characteristic, while the entity subtype each contain their own unique characteristics. So now what is entity supertype and subtype? We will explain it more with respect to some example. Like you consider that in case of employee, if we have a entity employee, we can have two type of employees: hourly employed and salaried employed. Okay, and similarly, if we consider an example of university, we can group our employee as faculty, staff and administrator. So entity supertype is employee, but employee, we have three different type of employee. We have a faculty, we have a staff, we have administrator. So employee can be a supertype, but faculty can be a subtype of supertype entity employee, and staff is also a subtype of supertype entity employee, and administrators is also a subtype of the supertype entity employee. So the characteristics that are for employee, that will be unique, that will be common. Employee entity will have a common characteristic, but each faculty, staff and administrator will have their own unique characteristics. They will have all the characteristic of supertype, but also they have some of their own characteristics. Okay, like here in the book, they give an example for aviation business, which employee pilots, mechanics, secretaries, accountants, database manager and many other type of employees. Now look, in this aviation business we have a lot of different type of employees. Now if we look at in this table, if you see that in this table, employee number is there for all of the employee last name, first name is there for all of the employee, but employee initial is there for some of the employee. Now employee license, this attribute is only applicable for pilots but not for mechanics or secretaries or accountants or database manager. So employee license, this attribute is null for first employee, but second employee who is the pilot will have this value over there, and then null for second next two employees, but again for other three employees it has some value who are the pilots. Okay, employee rating, so same is for employee rating, this attribute only applicable to the special type of employees who are pilots but not to other type of employee, and so on. So it is, if some of the attributes, if you see over here, is null for the other employee, or there are some attributes or characteristics which uniquely apply to some type of employees but not to all type of employees. So what we can do is we can handle this situation by creating a super type entity employee, and then we can create under this super type entity employee subtype entities, that is pilot, mechanic, secretaries, accountants, database managers. Now employee entity will have a common characteristic which is for all employee common, like employee number, employee last name, employee first name, and employee hire date. But other type of entity which can be null for most of the employee and will have value for some of the employee, we can, like employee license and employee rating. Now employee license and employee rating, these attributes are particularly related to the special type of employee which are pilots. So we will not keep it as a attribute in super type entity employee. We will have in super type entity employee only those attributes which are common for all, and those attributes which are unique characteristics will be allocated for subtype entities. Okay, these entity super types and entity subtypes are organized in a specialization hierarchy which represents the arrangement of higher level entity supertype. Entity supertype, you can also call it as a parent entity, and lower level entity subtypes which are also a child entities. So we can say that supertype entities are parent entities and subtype entities are child entities, and we represent the relationship between them through a specialization hierarchy. As shown over here in this figure, you can see that specialization hierarchy is formed by an employee which is a super type, and then we have three subtype of employees. One is pilot, other one is mechanic and accountant. So this is a specialization hierarchy between the super type and subtype entities, and this specialization hierarchy between employees and its subtypes represent one-to-one relationship between employee and its subtypes. Like an employee who is a pilot cannot be a mechanic. Okay, employee and pilot will have one-to-one relationship. Similarly, employee to mechanic is one-to-one relationship, and employee to accountant one-to-one relationship. The relationship here that we did not write, but it is when we have such type of super type and subtype entity relationship, it is called a is-a relationship. So for example, pilot is an employee, mechanic is an employee, and accountant is an employee. So this relationship between this super type and subtype entity is a relationship. Okay, other thing that is important to note down, that subtype exists only within the context of supertype. Like if supertype does not exist, if employee does not exist, then this subtype pilot will also not exist. So subtype exists only with the context of supertype, and every subtype has only one supertype to which it is directly related. Like pilot is a subtype of a supertype employee, but you cannot relate it to the other entity like dependent or somebody else. Okay, each subtype has only a one supertype to which it is directly related. In this figure, we just show the one level of hierarchy between supertype and subtype, but it is possible that we have a many level of this supertype subtype relationship. Like a pilot is become a supertype for another subtype if we have different type of pilots, like a flight based or monthly, salary based pilot, let's suppose. So we can have a pilot, a supertype, and then we can have a subtype of pilots over there. So we can have a different level of hierarchy or many level of this supertype subtype relationship. Okay, another concept that is used in enhanced ER modeling is called inheritance. This inheritance make it possible for entity subtype to inherit the attributes and relationships of the supertype. As we have discussed before, that a supertype contain attributes that are common for all the subtypes, and in contrast, like subtype contain only attributes which are unique to the subtype. Like we have seen in the previous example that pilot, mechanics and accountant all inherit the common attributes which are employee number, employee last name, first name and hire date from the employee entity. But then they have their own unique attribute, like pilot have their own unique attribute which is not present in mechanics and accountant. Like pilot have their unique attribute like license, rating, med type, as you can see here in this diagram. Now these attributes, last name, first name, initial, hire date and type, these are the attributes which are common for all of the subtypes. Like what are the attributes of entity pilot? Entity pilot inherit all the attribute of employee plus its own attributes, that is license, rating and med type. Okay, similarly mechanic, what are the attributes of mechanic? Mechanic inherit all the attribute of employee, that is last name, first name, initial, hire date, type plus mechanic title and mechanic certification or certificate. And same is true for accountant. So inheritance mean that entity subtype inherit attributes and relationship of supertype. And as I have already explained, that subtype and supertype maintain a one-to-one relationship between each other, or this is a relationship is one-to-one relationship, which mean that entity subtype inherit all the relationship in which supertype entity participates. So it not only inherit all the attributes but also inherit all the relationship as well. Like here in this diagram we can see that employee has one to many relationship with dependent entity. So the same relationship is between pilot and dependent, mechanics and dependent, and accountant and dependent as well. So here we just show the initial table that where we have employee. So employee become a super type and pilot become a subtype. So the attributes which are in employee are also part of pilot also inherit those attributes, although it is not written over here in this table, but it is inheriting because pilot is subtype, so it is inheriting all the attribute of employee plus its own unique attributes like pilot license, rating, and med type, and both table will have same primary key, that is employee num. Okay, a subtype discriminator is the special attribute in the supertype entity which determine to which subtype the supertype occurrence is related. Like, if we go back here in this example, the discriminator is employee type. So employee type is the subtype discriminator in the employee table. Okay, so from this attribute employee type, we can find out which type of the employee, pilot or mechanic or accountant. And we have added it over here in this table as well. If you see, employee type, P mean pilot, A mean accountant, M mean mechanics. Okay, also the default comparison condition for the subtype discriminator attribute is the equality comparison. However, in some situation, the subtype discriminator is not necessarily based on equality comparison. Like, we can consider an example based on business requirement. You might create two new pilot subtype, like pilot in command qualified and co-pilot qualified only. So pilot in command qualified pilot must have more than 1500 PIC flight hours. So in this case, the subtype discriminator would be flight hours, and the criteria would be greater than 1500 or less than or equals to 1500. Like, if it is greater than 1500, it means that this pilot is PIC qualified pilot, and if it is less, then it is a co-pilot. So most of the time it is based on equality comparison, but it's not necessarily to be equality, it can also be conditional. Like here in this example, we have equality discriminator based on equality comparison, that if employee type is equals to P, it mean it is a pilot. If employee type is equals to M, it mean it is a mechanic, and if it is equals to A, it mean it is a accountant. But it can be, like as I told you, based on conditional comparison as well, not necessarily always to be equality comparison. Okay, we have two type of subtypes. Like, we can say that entity supertype can have either a disjoint subtype or can have a overlap subtypes. Like, if we consider the same example where as per business rule we say that an employee cannot be a pilot and mechanic at the same time. So it means that pilot is having a disjoint, or it is a disjoint subtype of employee. So we can say that disjoint subtype, which we also call non-overlapping subtypes, are subtypes that contain a unique subset of the supertype entity set. Or we can say that each entity instance of supertype can present in only one of the subtype. Like, for example, if we go back here in this figure 8.2, it is showing here D. D mean disjoint or non-overlapping constraint. So we can say that an employee who is a pilot can appear only in the pilot subtype. He cannot be in any of the other subtype at the same time. Like, if an employee is a pilot, he cannot be a mechanic or accountant. He will be a pilot only. So it means they have disjoint constraint. If it is overlapping, it is represented with O symbol. Okay, now what is a overlapping subtype? Overlapping subtypes are those subtypes which contain non-unique subset of the supertype entity set. Or we can say that each entity instance of a supertype may appear in more than one subtype. Like, for example, if we take an example of university, a person may be an employee and a student, or both. Like you are an employee and you are a student at the same time. Okay, we have a super type person. Okay, and it has two subtypes. One is employee, one is a student. So a employee can also be a student as well. So it means it is a overlapping subtype. Here we have an example for it. Our super type is person. Okay, and we have two subtypes, employee and student of super type person. And then we have another level of hierarchy where employee is the super type of two types of employee, administrator and professor. So this is the administrator, and professor is subtype for super type employee. And same is for student. We have graduate and undergraduate are the subtype for super type student. Okay, so now we have two level of hierarchy over there. If you look between person and employee, person is employee, person is student, and here we have overlapping constraint. It means that there is some employee who are student at the same time. They are working somewhere and they are also studying somewhere. So employee can be a student, a person can be employee and student both at the same time. A person is an employee as well as student. So in that case they have this overlapping constraint or overlapping subtype. Okay, now again here for employee, employee is an administrator or employee is a professor. They again have overlapping subtype. So administrator is a overlapping subtype of employee. Like it is possible that there is a one professor who is also administrator, like dean, HOD. So they are administrator and at the same time they are professor. So this is again a overlapping subtype between employee and administrator and professor. But here you can see that between student and the subtype graduate and undergraduate, we have subtype that is disjoint or non-overlapping, because a student at a particular time can either be a graduate student or undergraduate student, but he cannot be at the same time graduate and undergraduate student. So they have this disjoint subtype. Okay, if we look at the discriminator attribute, for the discriminating attribute between person and employee and student is person is employee, person is student. Look, we have two discriminating attribute for super type person. Person is employee, person is student. Okay, now when we look here, employee and administrator and professor, so the discriminator attribute over here is employee is admin or employee is a professor. So these two are discriminator attribute between employee and administrator and professor. And the discriminator attribute between student and graduate and undergraduate is just student type, because they have disjoint. So we have one discriminating attribute, student type. If student type is graduate, it means he's a graduate student. If student type is undergrad, it means he's a undergrad student. Okay, so based on discriminating attribute, we can find out that what type of employee it is. If based on discriminating attribute between if we see over here, employee and administrator and professor, we have two discriminating attribute, employee is admin, employee is professor. So here we just write if employee is professor or is employee is admin. If professor yes and admin now, so it means employee is the member of professor subtype. But if professor no, admin yes, it means employee is the member of administrator subtype. And if it is yes for both, professor yes, administrator yes, it means employee is both a professor and administrator, and which shows that it is having a overlapping subtype. Then we have completeness constraint. So completeness constraint represent whether each entity super type occurrence must also be a member of at least one subtype. So the complete completeness constraint can be either partial or total completeness. Okay, if we have a partial completeness, it means that not every supertype occurrence is a member of subtype, and some supertype occurrences may not be a member of any subtype. But if we have a total completeness, it means that every supertype occurrence must be a member of at least one subtype. Okay, let's explain it through an example. Okay, one thing I just forgot to explain. Okay, partial completeness is shown by a circle over a single line, and okay, if we come back over here, okay, partial completeness is shown with a circle on single line, and complete or total constraint is represented with a circle on double line. Okay, if we go back over here, you can see double line and circle, which shows total completeness, and here it shows partial completeness, and here it shows total completeness. Okay, when it is showing total completeness, as we say that every supertype occurrence must be a member of at least one subtype. Like every time when we have a entity person must be one of the type either employee or student. Okay, so it is assumed like that, so it is total. But here we can see that here we have partial completeness. It is possible that we have a employee over here which is not a administrator, neither a administrator nor a professor, maybe some other type of employee like staff. Okay, so it means that not every supertype occurrence is a member of subtype. Supertype employee, there is one occurrence of supertype which is neither administrator nor professor, so it is shown here through partial completeness. And here if you see, again we have a total completeness. It means if we have a student occurrence, it will always be either a graduate or undergraduate student. Okay, so in case if we have like we show over here, or we compare partial and total completeness with respect to overlapping and disjoint constraint. So here we show that if we have a partial completeness and disjoint constraint, it means that supertype has optional subtype and subtype discriminator can be null. So it is possible that subtype discriminator does not identify any of the subtype. Okay, this supertype is a unique occurrence which does not belong to any subtype, and subtype sets are unique. In case of overlapping, they said having a same two characteristic, like supertype has optional subtype and subtype discriminator can be null, but because we have overlapping constraint, because of this subtype sets are not unique, because in case of overlapping it is possible that two subtypes belong to, like your discriminator attribute belong to both subtypes, so subtype sets are not unique. Okay, in case if we have total completeness, then with respect to disjoint constraint, it has some special characteristics. First is, because it is total completeness, it means every supertype occurrence must be a member of only one subtype, like and it is also a disjoint. So you know that if a student, it can be either a graduate or undergraduate, but not both at the same time. And subtype discriminator cannot be null, it must belong to either one category. It can be either a graduate or undergrad, but it cannot be a null. Discriminator cannot be a null. And subtype sets are unique. Why it is unique? Because it is belonging to disjoint constraint. But in case of overlapping constraint, we can say that every subtype occurrence is a member of at least one subtype, because we have overlapping, and subtype discriminators cannot be null, and subtypes are not sets are not unique because it is overlapping. Okay, how to identify that whether we have to group these entities into one supertype, or we have a one generic entity and we have to divide it into several subtypes. So for this we use different approaches. One of the approach is specialization and other one is generalization. Now specialization is also called top down process, where we identify more specific entity subtypes from higher level entity supertype. It means like you have first decided about a supertype entity, and based on supertype entity you can find out different type of subtype entities. So it is a top down approach. And specialization is based on grouping the unique characteristics and relationship of the subtype. Like if we look at the aviation example, you need specialization to identify multiple entity subtypes from the original employee supertype. Like we first consider supertype employee, and then after, based on different unique characteristics and relationship, we find out that okay, employee can be further subdivided into mechanics, accountant, pilot. Okay, second approach that can be used to identify supertype and subtype is called generalization. It is bottom up process. So we identify more generic entity supertypes from subtypes. We already have a subtypes, and we find out that these subtypes have some of the common characteristics, so why not join them together to one supertype entity. Okay, so you first identify subtypes, and then based on the characteristics of subtypes you find out that why not categorize them together in one supertype. So it is bottom up process, subtype to supertype identification. And again, specialization it is based on grouping common characteristics and relationship of the subtypes. Like for example, you might identify many types of musical instruments like piano, violin and guitar, and then using the generalization approach you can find out a string instrument entity supertype. Like you can say that piano, violin and guitar, I can put them all together in one supertype entity string instrument, because they all have common characteristics. So why not join them together to one super type entity like string instrument. Okay, entity clustering is a tool that is used to reduce the number of entities shown in ER diagram. Because when you are developing ER diagram, initially you might have a few entities in your ER diagram, but as you add more detail into your design, the ER diagram will start expanding and start having more number of entities, and at one point of time you will have ER diagram which might contain 100 of entities and relationship, which make the diagram very difficult to understand. So at that time what we do is we perform entity clustering. So what is the entity clustering? We want to minimize the number of entities shown in ER diagram so that we can see ER diagram more neatly, or we can understand it better. So our entity cluster is created. What is an entity cluster? It is a virtual entity type which is used to represent multiple entities and a relationship in ER diagram. So how can we form entity cluster? It is created by combining multiple interrelated entities into a single abstract entity object. So we consider it as a virtual or abstract entity. Why we consider it that? Because it is not actually an entity in final ER diagram, but it is just a temporary entity which is used to represent multiple entities and relationship with the purpose of just simplifying ER diagram. Because we want to simplify ER diagram, so we just create this temporary entity. Like here in this diagram we have two entity clusters shown over here. One is location and one is offering, and when we are creating these cluster, we do not display the attributes because to not confuse others. So location and offering are representing over here as a cluster entity, where if you see tiny college diagram, you can find out that location is basically grouping the two entities, room and building. So room and building, we group them together into one entity cluster, location. And similarly offering is grouping two entities, courses and class. So we just group them together in one entity, offering.